Welcome to this video on compound interest. Let's begin. Suppose that P dollars, which is the principal, is invested or borrowed at an annual interest rate R for T years. If this is being compounded periodically, then we would say the amount A in the account after T years with N compounding periods can be represented by the equation A equals P times the quantity 1 plus R over N, quantity to the NT power. Sometimes, instead of being periodically compounded, interest is continuously compounded. In this case, the amount A in dollars in the account after T years under continuous compounding can be represented by the equation A equals P E to the RT. In case you've forgotten, E is a natural number, which is approximately equal to 2.71828. Remember, it is an irrational number that cannot be expressed as a ratio of two integers. It is a non-repeating, non-terminating decimal. Let's go through some of these values and make sure we understand what the variables represent. Both of these equations, the periodic compounding and the continuous compounding, contain P. But what does P represent? Well, P represents the principal. So this is the initial or starting amount of money that you invest. Or if this problem is about borrowing money, then it would be the initial amount of money that you borrow. All right, let's keep moving. So now the next variable that we see is the A. So A represents the amount of money that you have after T years. So both equations also include A. Some questions, instead of referring to this as A, the amount, they will also refer to it as the balance. So if you see a question that's asking you for the balance, that's also what you are looking for. Okay, so it's asking you to find A. Now, if the problem is about, instead of saving money and getting interest or accumulating more money, instead of that, if it's about borrowing money, then A would be the total amount you owe after a certain number of years with interest. Okay? So what is this interest we're talking about? Well, we're talking about an interest rate. So what is an interest rate? That means that if we're investing money, we end up with more than we started with. Or if we're borrowing more, we actually end up owing more or paying more than we initially borrowed or paid for the item. For example, if you buy a car that's worth $20,000, right, you're probably going to need a loan, at least for part of that money. So you end up paying the loan, the person who's giving you the loan, the bank or the car seller or whoever, you're going to pay them more money than the car was actually worth. Okay, so the interest rate is expressed as a decimal, and we'll talk about that a little bit more. So you can see that both equations contain R, and again, R is the interest rate. Okay, the rate at which interest is accumulated. So then we can also see that both equations have a T, and T, as you can sort of imagine, is time. So the longer it takes you to pay back a loan, or the longer you leave your money alone in a bank to collect interest, the more money either you'll have if you're investing money, or you'll owe if you have a loan. Okay, so then the last thing is N. Okay, it's funny I didn't put a name here. I didn't really have a good name for it. So the explanation of N is the number of times per year that interest is compounded. So if we look at it, only one of these equations has an N. Why is that? Well, because periodic compounding means that the interest is compounded or calculated N times in a year, right? So if it's only done once a year, N would be 1. If it's done every month, N would be 12. Okay, but then we have continuous compounding, which means it's done instantaneously every moment. So that's why, because there is no compounding period for continuous compounding, that is why the second equation, A equals P E to the RT, does not contain N. We'll find, and this is sort of an advanced topic, you don't really need to know this, but as we let N get larger and larger, meaning that we compound our interest more and more frequently, this value of this equation approaches continuous compounding, which makes sense. Okay, so let us go through some common values of N. So if we are compounding annually or yearly, right, we are compounding once a year. So that means that n is equal to 1. Semi-annually, that literally means every 6 months. So that's twice a year. Okay, monthly, there's 12 months in a year. So n would be 12. Weekly, you may or might not know there are 52 weeks in a year. About, because a leap year is not exact, but we just say n is 52. Daily, there are 365 days, sort of, in a year, right, except for leap year. So n equals 365. And continuous, remember, for continuous compounding, we don't need n. In fact, for continuous compounding, we cannot use this equation, right? For continuous compounding, we have to use a equals pe to the rt. In other words, there is no n. All right, so before we get started with some questions, I want to go over some common mistakes. So the biggest thing that I see some people do or make mistakes on is converting a percent to a decimal. So remember, percent is Latin. It literally means out of 100. Per means out of, cent means 100. So 3% literally means 3 out of 100. If you type that into a calculator, it gives you 0.03. So this is the value that has to go into your equation. Let's do a few more examples to get really comfortable with this process. So 5.5%, again, 5.5 divided by 100. So type that in your calculator, you should get 0.055. Okay. Likewise, 8% is 8 out of 100. Type that in a calculator and you get 0.08. Okay. 1.25% is 1.25 over 100. So that's 0.0125. Okay. So make sure you are comfortable with that process. Okay. And you're careful. A common mistake I would see is, for example, instead of writing 0.03 into the equation, sometimes people write 0.3. Right? Or instead of 0.055, they might write 0.55. Or instead of 0.08, they might write 0.8. Okay? So the number of zeros between the decimal point and the first number definitely matters. So please be careful and watch that as you do these problems. Okay? Another thing that can be slightly confusing is how you type these into a calculator, right? Because the order of operations matters. Okay, you might need to use parentheses or do them in multiple steps, and I'll try to show you how to do that. Okay, the other thing is that those two equations that I just showed you are not provided for you, unfortunately, so you need to know those two equations. So make sure you work on memorizing them. All right, let's go ahead and get started on our first example. It says, suppose that $15,000 is invested with 2.5% interest under the following compounding options. Determine the amount in the account at the end of 7 years if the interest is compounded: A, annually, B, quarterly, C, monthly, D, daily, or E, continuously. Okay, so most of these values, in fact, all of them except for one, are going to be the same for all parts of this question. So let's see if we can take a minute and practice identifying the values, the important values in this equation, right? And then going through and seeing if we can map them to the variables that are being given to us. Okay, so the first number I see is $15,000. Where should $15,000 go? Well, $15,000 is the initial amount. So that is going to be our principal. It's the amount of money that we started with. Okay. Then the next number that I see is 2.5%. So 2.5% is my interest rate. However, I can't write 2.5% here. So remember in the last slide, what did we just talk about? We need to convert 2.5% to a decimal. So percent, remember, it means out of 100. If you type that into your calculator, you get 0.025. So for the interest rate, we need to write 0.025. Okay, and then last but not least, we're given the time. So the time that we're given here is 7 years. Also, a quick note, if your time is not being given to you in years, you have to convert it to years. So let's say that the time was like 18 months or something like that. I'll try to do an example with that. You would have to convert it to years before you can continue. Okay, so again, t always needs to be measured in years. If it's not in years, you have to do some modifications yourself. Okay, so then now we can start doing A, B, C, D, and E. So let's start with part A. A says compounded annually. So annually, remember, means once a year. And if we go back to our chart here, right, annually or yearly means that n equals 1. So let's go ahead and fill that out. Okay, and now we can think about what equation we need to use to solve this. So now that we have all of our variables filled in, now we need the equation. So remember, this is something you're going to have to commit to memory. So let's see if we can fill this in. So what is our A? Well, A is the question, right? What we're trying to find out. We don't know what A is right now. But we do know what P is, right? P is our principal. It's our starting amount. In our case, P is $15,000. Okay, so we have 15,000 times the quantity 1 plus R. Well, R is 0.025. Okay, and then N we said was 1. And then we have it raised to the 1 times 7 power. So let's try to simplify this before we, try to type it into our calculator. So this is going to be 15,000 times 1 plus 0.025 raised to the 7th power. Well, I can simplify that a little bit more. So I have 15,000 times 1.025 raised to the 7th power. So let's think about our order of operations, right? Please excuse my dear Aunt Sally. What do we have to do first? Can I multiply these two numbers first, or do I have to do exponents first? Well, I have to do my exponents first. So again, going back to those common mistakes, right? Your order of operations. So the first thing we have to do is type in 1.025 to the 7th power into a calculator. Okay, and when I do that, okay, we'll have 15,000 times, and it's about 1.1886857, sorry, I read it wrong, 575, and that's good enough, okay? So we take that number and we multiply it by 15,000, and of course, because this is money that we're talking about, we're gonna round it to the nearest cent. So I get $17,830.29 because it's 286, right? And 286 rounds to 29. Okay, so that is our final answer in dollars. All right, let's do the next one. Again, everything is exactly the same except for the compounding period, right? So we have quarterly, so that means 4 times a year, so n is equal to 4. So we're still going to have our principal, which is 15,000, times the quantity 1 plus R, 0.025, divided by 4, because n is 4, raised to the 4 times 7 power. Okay, so think back to your order of operations. Please excuse my dear Aunt Sally. The first thing we have to do is this guy right here. So if I put that into a calculator and notice that I'm writing the whole equation all over again, okay, I get 0.00625, okay? So I get 1.00625 in the parentheses. All right, 4 times 7 is 28, okay? So again, think about your order of operations. We have to do the exponents first, right, before we multiply, okay? So when we do that, we get 15,000 times 1.195976, so on and so forth. Okay, so last but not least, let's multiply those two numbers. Okay, and when we do that, we get 15,000. Oops, sorry, we don't get 15,000. I apologize. We get 17,858 and 96 cents. Okay, so that's our final answer. So let's take a minute and compare what we got when we compounded annually with what we get when we compounded quarterly. Okay, so here we have 17,830. So 17,830, here we have 17,858. So remember, our last number was 17,830.29. Okay, so this is compounding at once a year. This is compounding at 4 times a year. So which one is larger? Well, you can see that it's larger. It's a little bit larger, only by like $28, which isn't a ton, right? But it's slightly larger when we compound it 4 times a year instead of once. Okay, so let's see how it changes with part C. So now we're compounding monthly. Again, there are 12 months in a year, so n is going to be equal to 12. Okay, so we still have our principal, that's 15,000 times 1 plus our interest rate, 0.025, divided by 12 this time, because our n is 12, to the 12 times 7th power. So first we simplify the expression inside the parentheses, and we get what you can see here. Okay, then we have to raise that number to the 84th power. So we have 15,000 times about 1.191029383, and so on. Okay? So when I type that into a calculator, I get $17,865.44. Okay? So again, let's compare the monthly compounding to the other one, right? So before we had 17,858, 17,858. Okay, so you can see when we go from quarterly to monthly, it's still increasing from 58 to 65, but this time it's not increasing as much, right? It's only increasing by what, like about $7 or so. Okay, so let's do our last periodic compounding, which is daily. So daily, right, there are 365 days in a year, so we say n is 365. Okay, so our equation is going to be 15,000 times 1 plus 0.025 divided by 365 raised to the 365 times 7. And once again, if I go through all of those steps, I get 17,868.59. Okay, so that would be our final answer. Let's compare that value to the monthly compounding. So this was 17,865, 17,865 and something. So you can see when you go from monthly to daily, the increase in the amount of money you get is even less. Okay, so let's do number 1, part E. So this time we're compounding continuously. So what is n if we're compounding continuously? Well, remember, for continuous compounding, we use a different equation, and this equation, as you can see, does not contain n. So we don't even need an n. So let's go ahead and fill this out. So the amount that we have, right, is the principal, that's 15,000. E, remember E is just a number, okay, and your calculator knows what it is, even if you don't. E to the 0.025 times 7 power. Let me write that better over here because it's kind of squished there. So we have e to the 0.025 times 7 power. Okay, so let's think about order of operations. Again, please excuse my dear Aunt Sally. We have to evaluate the exponent first, right, before we do our multiplication. Now the cool thing is most calculators, you can just type this whole thing in there and get your answer. So when I type that into a calculator, I get $17,868 and about 69 cents. Okay, so let's compare that number to what we got in by compounding it daily. So this one was $17,868.59. So when we compare, right, this is n equals 365. Right, this is n, there's no n because we're continuously compounding, right? There's only a 10-cent difference, okay? So again, as we increase n, we get closer and closer to continuous compounding, we kind of saturate there. All right, so that was an example 1. I'm going to do one more example, as you can see here, example 2. And again, I would encourage you to pause this video, try to do some of this without me, and make sure you understand how to find the values that are of interest and so on. Okay, so it says, suppose that $10,000 is invested with 1.5% interest under the following compounding options. Determine the amount in the account at the end of 3 years if the interest is compounded and so on and so forth. Okay, so first of all, what is the principal? The principal is $10,000. The interest rate is 1.5%. So remember 1.5%. Percent means out of 100. So 1.5 divided by 100, you can put that in your calculator, is going to give you 0.015. 0.015. And again, the time, of course, is 3 years. Remember, time has to be in years. If your time is not measured in years, you have to fix it so that it is. Okay? So if we're compounding annually, then our n would be 1. Okay? So let's see if we can fill in our equation. So we don't know A, the amount. That's what we're being asked for. So we can say that A is equal to our principal. Remember, our principal, our beginning amount of money that we're investing is $10,000. So we have 1 plus 0.015 over 1 raised to the 1 times 3. So this is going to give us 10,000 times 1.015 to the third power. Again, remember your order of operations. You cannot multiply until you resolve your exponent. So now we have $10,000 times 1.045678375. Okay, and then we multiply those numbers, and we get $10,456.78. So that would be our final answer for a single compounding per year. All right, let's keep going. So now suppose we're compounding quarterly. Again, the only thing that changes is our n here. N would be 4. We're compounding it 4 times a year. So we have 10,000 times the quantity of 1 plus 0.015 over 4 raised to the 4 times 3. So 0.015 divided by 4 is 0.00375. Okay, 4 times 3 is 12. So then we would have something that looks like this. And again, we have to do the exponents before we can multiply. Okay, so then we get $10,000 times 1.04593982504. And that gives us $10,000 plus 459.40. Okay, so $10,459.40 would be our answer. All right, so let's do monthly. So remember, monthly means n is 12. Okay, so we have $10,000 times 1 plus r is 0.015. N is 12, and then we have 12 times 3. Okay, and when we calculate this, we get 10,459.98. Okay, and then we want to do daily. So again, that's almost the same. The only difference is our n. Our n is 365 this time. So we have $10,000 times the quantity of 1 plus 0.015 divided by 365 raised to the 365 times 3 power. Okay, and when we evaluate that, we get 10,460.27. So that would be our answer. So last but not least, what about compounding continuously? How do we do that? So remember, when we compound continuously, we don't have an n, right? We have to use this different equation, which is that A is equal to P, our principal, 10,000, e to the r, which is 0.015, times, in this case, 3. Okay, and when I enter that into a calculator, I get 10,460.28. So $10,460.28.